So let's say we want to have a function, so we have a function f, and it will just print, function. That, and then, well, we can call it, right? And if we compile it, it will print function f, right? But if you have a lot of functions, and well, if you want to reuse functions on different files, well, you can put it in the nar file. So let's say f.h, and then we put it here, and then we can include it, right? f.h, and then that will just include all the things in the file into our current file, and so we can actually use it. So it prints again f, right? But usually you don't see that. Usually you just see f.h, which contains just the function declaration, so only the return value and the arguments, but you don't actually see the implementation of the function. And you see the implementation implemented in the .c file. And there are reasons for that, but let's do this, I guess. Let's include the .h file and let's see if it actually works. So, and it doesn't. Undefined reference to f. Well, why does it happen? Well, we only included the .h file, which contains this thing, right? Only the declaration, but we aren't actually giving the compiler knowledge of what f actually does, and that's why it doesn't know what to do with f when we call it. So how do we actually make it work? Well, you'd probably want a make file or script. So let's make a script, or make, and then you'd have your main.c, your compiler, and well, you'd actually want to compile the .c files, so the function .c, if you have multiple .c files, you would want to compile them into an object file first, and you can do that with C, I think, maybe f.h, and then you want to include the object file, the .o file, when you compile the main function, or not function, the main .c file, right? So if we have this chmod make no such file f.o, wait, gccc, is that wrong? f.h, f.o, how do I make .o? How do I make a .o file? Wait, no, I need to compile the .c file, not the .o file. That will compile it into a pre-compiled header. So let's do make. Oh, we haven't included stdio here. So, but if we include it, make, and well, if we see, now we have the .o file for the .c of f, and actually we should make the output main, because I don't want a. So if we do this and then we do main, well, it will not work. But well, why would you actually want this? Why not just put everything in the .h file, and everything works just fine. You don't need to actually make a script, and you don't need to actually compile the .c files into an object file. You just include everything in the .h file, right? Well, you can include everything in the .h file. It will be as though you only have one file, right? But you're just including different files into a file, and then you are just compiling that file, right? But when you have a large program, every time you make a change, you are recompiling the whole program. So everything, every function you're compiling, every function for every little thing you are changing. When you have separate .o files, when you have separate .c files, which you will compile into an object file first, you can compile them independently, and then you only need to combine them when you actually include all the object files with the main file. But the thing that's going to take a long time to compile, you can do independently. So you can actually use multiple cores. And when you make a change in, let's say, f.c, you don't need to recompile every object file. You can just reuse the old object files and just recompile the f.c. So in your script, before actually compiling, you can test that the .o file, whether it is actually older than the .c file. Because if you have actually made any change, it's going to be newer, right? And it's going to need to recompile. Otherwise, you don't need to recompile the .o file.